Hello students, today I am going to cover up unit number 4, lecture number 1, transport layer. In this video, I will cover up some of the basic of the transport layer. Transport layer is the middle layer of the ISO OSI model. That is, it is numbered as fourth from top as well as from bottom. While in case of the TCP/IP model, it is numbered as second from the top and third from the bottom. At the sender end, transport layer receives the data from session layer and divides into smaller chunks. These chunks are known as segments. These segments are forwarded to network layer after attaching header with each segment. As depicted in the figure, at the sender end, the data received from the session layer is divided into number of parts. Each part is attached with a header H4. Here H stands for the header and 4 means layer 4, which is the transport layer. After this, these segments are forwarded to the network layer. At destination end, it removes the header from each segment and assemble into single units. That is known as the data and forwarded to session layer. As depicted in the figure, at receiver end, the header part is removed by the session layer and combine these data into the single unit and forwarded to the session layer. Transport layer protocols. There are three basic protocols at the transport layer. They are named as transmission control protocol, which is a connection oriented protocol. UDP, that means user datagram protocol. It is a connectionless protocol, and stream control transmission protocol SCTP. It includes the feature of both TCP and UDP. We will discuss these protocol in future lectures one by one. Now, I am going to discuss about the services, or you can say duties, goals, or responsibilities of the transport layer. The basic services offered by the transport layer are listed as follows. First service is the process-to-process communication. Next one is the service point addressing. It is also known as service ports addressing, multiplexing and demultiplexing, connection control, order delivery, flow control, error control, congestion control, and quality of service. We will discuss each service one by one in detail. First one is the process to process communication. In real communication take place between two processes. Therefore, there is need of the process to process delivery. At any instance of time, several processes may be running on the source host and the destination host. Here, as diagram depicted, there are number of processes running on the sender as well as number of processes are running at the receiver. Transport layer provides the facility to deliver the data from one of these processes running on the source host to the corresponding processes running on the destination host. For example, the source having is using the protocol port number 23, that means telnet, and it wants to communicate at the destination with the telnet. So it will communicate the process that is running on the port number 23. Each process is uniquely identified by the process identification number. In Unix or Linux, it is known as the PID. In short, the transport layer is responsible for process-to-process delivery of the data packet, while the network layer was responsible from host-to-host delivery of the data packet, and the data link layer was responsible for delivery of node-to-node frames. Service point addressing. Transport layer header includes a special address that is known as the service port address or the port address. It is a logical entity It has the size of 16 bit. Each protocol is associated with a unique port number. For example, TCP, the 20 port number and 21 port number are attached with the FTP, 23 with the telnet, 25 with the SMTP, 53 with the DNS, 80 with the HTTP, and so on. So these are the some of the list of well-known ports that is used by the services. Service point addressing. Internet Assigned Number Authority is responsible for assigning the port number. These port numbers are divided into the three categories: well-known ports, registered ports, and dynamic port, also known as the private ports. Well-known ports. The ports ranging from 0 to 120, 1023 are registered and controlled by the IANA. These ports are known as the well-known ports. For example, port number 80, port number 23 for telnet, port number 25 for SMTP, and so on. Registered port. These ports are ranging from 1024 to 49151, are not assigned or controlled by IANA. They can only register with IANA to prevent duplication. Third and last one is the dynamic ports. These are generally used by the application developed by the programmers. These ports ranging from 491522 to 65535. These are neither controlled nor not registered by the IANA. They can be used by any processes. So here is the representation of well-known ports, registered port, and dynamic ports. Now let us discuss about the socket address. The process-to-process delivery needs two identifier, IP address and port number for each end-to-end connection. The combination of IP address and port number is called socket address. Here, as shown in diagram, this is the IP address of a particular computer, and this is the process that is running on a particular port. So the combination of the IP address and the port number is known as the socket address. The client socket address defines the client process uniquely, and the server socket address defines the server process uniquely. A transport layer protocol needs a pair of socket addresses, that are the client socket addresses and the server socket addresses. This can be easily understood with the help of the TCP socket. Suppose that a number of clients wants to communicate connection oriented services to the server. So that means they want to communicate using the TCP socket. So if server creates a socket, it will bind up an IP address and the port number with it and start listening for the request from the client. Similarly, the client will create a socket and it will try to connect with the server. As it sends the connection request, the server will accept it and wait for the query from the client side. The client will write the query and send to the servers. The server will read it, and corresponding to that, it will fetch the data and write to the client end. The client will read it, and again, if it has the query, it will resend to the server. This process will continue. When the client will bind up their request, it will send the close request to the server. The server will read it and disconnect the connection. It- this may be possible. A number of other clients may be communicating with the server, so server will not close itself. When all the clients will close themselves, the server can now close itself. Now, next topic is the multiplexing and demultiplexing. A number of processes may be running on a host, so there is a need of the multiplexer that can combine these processes and send to the network layer. Similarly, at the destination transport layer, there is a need of the demultiplexer that can separate those processes. So, multiplexing at the sender side, there may be several processes that need to send the packet. However, there is only one transport layer protocol at any time. This is a many-to-one relationship and required multiplexing. For example, there are number of processes are running on a single computer. These processes will combine. These are the many one, two, three, and combined into the one. So many to one relationship and send over the network. The protocol accepts the message from the different process differentiated by assigned port number. After adding the header, the transport layer passes the packet to the network layer. At the destination end, the relationship is one to many. That means it will convert the received packet into the number of segments. After checking the error and dropping the header, the transport layer deliver each message to the appropriate process based on their port number. The Google to the Google one, Outlook to the Outlook one, and chat room to the chat room. Now, connection control. The transport layer can be have two type of connection oriented or the connectionless. So firstly, we will discuss about the connection oriented services. The connection oriented services, there is a need of the connection establishment before exchange of the data between the sender and receiver. This process is known as the handshaking. In real life example, suppose that I want to communicate with the some person, so I will interrupt him by hello or excuse me. So this process will known as the handshaking. There is a sequence of operation followed by the user in the connection oriented. Firstly, establish the connection, then after transfer the data, and at the last release of the connection, so that another process can use that particular source or the destination. For example, the connection oriented protocol is used by the TCP and SCTP. Another one is the connectionless services. In the connectionless services, there is no need to establish the connection between sender and receiver. The sender can send the data without ensuring whether the receiver is available to receive the data or not. For example, in our television, the satellite is continuously sending the data whether our TV is on or not. The packets are not numbered. They may be delayed or lost or may arrive out of sequence. There is no acknowledgement for the example of the connectionless protocol is the UDP. Now, at the last, I am discussing the reliable versus unreliable connection at the transport layer. When we want to make the secure connection, then there is a need of the reliability. For example, the data must be reached to the destination without any error, something like that one. So this comes under the category of the reliability. The transport layer service can be reliable or unreliable. If the application layer program needs reliability, we use the reliable transport layer protocol by implementing flow and error control at the transport layer. This means the slower and more complex services will be, and there will be a delay also. On the other hand, if the application program does not need the reliability because it uses its own flow or error control mechanism or need fast services or nature of the services does not demand the flow or error control in such as in real-time application, then the unreliable protocol can be used. So this was all about the basic of the transport layer. If you have any query, you can contact to me my mail ID. Thank you.